Chapter 9 is on testing a claim. Section 9.1 is going to cover the basics to doing a significance test. In this section, we're going to learn how to state correct hypotheses for a significance test about a population proportion or a mean. And also in this section, we'll look at interpreting a p-value in context of the problem. In Chapter 8, we looked at confidence intervals. The goals for a confidence interval were to estimate a population parameter. In Chapter 9 now, we're going to look at another type of inference that's called a significance test. The goal is different now. The goal in a significance test is to test a claim about a population parameter. The claim that we're looking at in a significance test is referred to as a hypothesis. This section looks at the logic behind a significance test, and Section 9.2 and 9.3 will actually get into how to calculate and run all the way through a significance test for means and proportions. Statistical tests deal with claims about a population. Tests ask if data is given as good evidence against a claim. A test might say, if we took many samples and a claim were true, we would rarely get a result like this. To get a numerical measurement of how strong the sample gives evidence, we replace the vague term rarely with a probability. Here's an example. Suppose a basketball player claims to be an 80% free throw shooter. To test this claim, we have him step to the free throw line and shoot 50 free throws. He makes 32 of them. His sample proportion, or p-hat, would equal 0.64. What can you conclude about his claim based on this sample data? Well, like in Chapter 8, we could go ahead and calculate a confidence interval and see if 80% lies in the confidence interval, but we're actually not going to do that. We're going to actually test the claim and come up with a value to see how close his 64% is to 80 and to see if that's a rare occurrence or not. So what you could do is you could use statistical software and simulate 400 sets of shooting 50 free throws, assuming that the player is really an 80% shooter. If you did that and did a dot plot, it may end up looking like this. In taking a look at this dot plot and finding 0.64 on the x-axis, you can see that only 3 of the 400 sets of 50 shots gave us a value of 0.64 or lower. So you can say how strong the evidence against the player's claim is given the probability that he would make as few as 32 out of 50 free throws as he really makes 80% in the long run. The observed statistic, p-hat, is so unlikely that the actual parameter is 0.80 that it gives convincing evidence that the player's claim about shooting 80% is actually not true. Based on the evidence, we might conclude the player's claim is incorrect. In reality, there are 2 possible explanations for the fact that he made only 64% of his free throws. The first one being, the player's claim is correct. He is actually an 80% free throw shooter, but he had bad luck that day, and a very unlikely occurrence actually did happen. The second possible outcome is, the population proportion is actually less than 80%, so the sample result is not an unlikely outcome. The basic idea of doing a significance test is this. We're trying to see if an outcome that you get would rarely happen if a claim were actually true, and it gives good evidence that the claim is not true based on how few of times it would happen. In this case, only 3 out of the 400 times would it be 0.64. So again, we don't know for sure which one of these is true. Maybe it was just a bad day, but more than likely, because it would happen so rarely by chance, that he's probably actually not an 80% free throw shooter. That's kind of the reasoning behind significance test. When you actually do a significance test in section 2 and 3, one of the steps in your process is going to have to be stating the hypotheses. A significance test starts with a careful statement of a claim we want to compare. The first claim is called the null hypothesis. Usually the null hypothesis is a statement of no difference. The claim we hope or suspect to be true instead of the null hypothesis is called our alternative hypothesis. Here's our definition of null hypothesis and alternative hypothesis. The claim tested by a significance test is called the null hypothesis, or H naught, H sub 0. The test is designed to assess the strength of evidence against our null hypothesis. The claim about the population that we are going to try to find evidence for is called the alternative hypothesis, or H sub A. If you think back to the free throw example, the free throw shooter claimed his average, or p-value, for shooting free throws was 80%. So our null hypothesis then would be p is equal to 0.80. Based on our sample, and he only hit 64% of the shots, our alternative then would be to try to show that p is less than 0.80. P again is the long run proportion of the free throws that he would have been made. A little bit more on stating hypotheses. In any significance test, the null hypothesis will have the form H naught is equal to the parameter is equal to some value. Now the parameter could either be a p or a mu. If you're dealing with proportions, it will be a p-value. If you're dealing with means, it would be a mu value. The alternative hypothesis then would have one of these three forms. The alternative could be the parameter is less than a value, as it was with our free throw example. The parameter could be greater than a value, or the parameter might just not equal a value. You have to read the problem very carefully to determine the correct form of your alternative hypothesis. But if you do a good job of reading the problem, you should be able to figure out from the wording in the question. Definitions again of one-sided versus two-sided. The alternative hypothesis will be called one-sided if it states the parameter is larger than the null hypothesis value, or if it states the parameter is smaller than the null hypothesis value. The alternative will be considered two-sided if it states the parameter is different from the null hypothesis. It could be either larger or smaller. We don't care in which direction it's going. All we care about is there's a difference. Two things to remember here. Hypotheses always refer to a population, not a sample. So be sure that your null hypothesis and your alternative hypothesis are in terms of the population parameters, not statistics. It's never correct to write a hypothesis about a sample statistic, such as p hat is equal to 0.64 or x bar is equal to 85. They must always be written in terms of a parameter and not a statistic. This is basically the first step of a significance test. We will study the rest of the steps in future lessons.